Okay, so before we found the slope of a curve at a single point, but now we'll find the derivative of the curve, which basically tells you the slope at every single point. Right, so maybe if we calculate the slope here at this point, P, we might find that the slope is 1.8. And over here, maybe the slope is 0.2. And what we want is to know the slope at every single point of the curve. So here are the exercises for this section. Let me just show you what the answers are, and I'll leave you to figure out how to do it. But if this is your curve, namely y equals x squared plus 1, then the derivative, dy dx, is a new function, 2x. This tells you the slope at every single point, all infinitely many. Okay, so for example, at x equals 3, y is equal to 10. So the point 3 comma 10 is a point on this curve, and the slope there is apparently 6. Because I just plug in x equals 3 to this formula and it tells me 6, and so that's apparently the slope at this point of this curve. So this formula tells you the slope at infinitely many points. We could write f of x equals x squared plus 1. Then we might write f prime of x equals 2x. Like this notation, these both mean the same thing. Another notation would be to write df dx. And all those are just different ways to write the same thing. Now, how do we actually compute this? So let's go back to our old example of y equals x squared. We found the slope at this point is 2, and at this point is negative 4. So how do we find the slope at every point? So what we do is we think, what if we're at some arbitrary point, x comma f of x, which in this case is x squared. Then what we'll do is we'll just take whatever that x value is and nudge it, move it a little bit by h to get to the point x plus h. Follow that up will give us some new point at the curve whose x-coordinate is x plus h and whose y-coordinate is f of x plus h. Or in this case, because f of x is x squared, then for our example, this is squared. Now what we do is we just do the exact same thing we did before. We form the Newton quotient. So this is a name. When things come up a lot, it's helpful to give them a name. So this is called the Newton quotient. What is it? It's f of x plus h minus f of x. That's the subtraction of y values, the change in y, the rise. Now what's the run? It's x plus h minus x. That's the change in x values, the x2 minus x1 or whatever. The delta x, which, by the way, in every single case will be just h. So in fact, we can just write the denominator as h. Then let h go to 0, and that will give you your answer. So what some people write would be f prime of x, or the derivative df dx, or dy dx, all these different ways to write the same thing, equals the limit as h goes to 0 of what? Of the Newton quotient. Okay, and so let's compute this for this specific function. So now I'll change to a different color. Let f of x equal x squared. What is the derivative? Well, the derivative is now in words what all these things mean in symbols. And specifically, it's the limit of the Newton quotient. Newton quotient. Quotient means you're dividing things, and it's really just the rise over run. Okay, so what is it? Well, what's f of x plus h? Now, minus f of x. You see how I've used our specific function? The bottom is always going to be h. Now what I do is I expand this squaring out. I still have to subtract the x squareds, and those will cancel. And then I still have to divide by h. So now I get a 2xh divided by h, that's 2x, and an h squared divided by h gives me a plus h. Now, let h go to 0. Thus, the answer is 2x. Okay, so that's basically it. We just choose an arbitrary point x, wiggle a little bit, and then let h go to 0 after we take the Newton quotient. Okay, so now notice when we first form the Newton quotient, if we try to let h go to 0 too soon, we fail. Because we have a divide by 0, and then we have, so if h goes to 0, then x plus h squared just becomes x squared. X squared minus x squared is 0, and then we have to divide by 0, and we get 0 divided by 0, which it's whatever it is. What you can say whatever it is, it doesn't look like it's 2x. So this sort of fails unless we first do some algebra with the Newton quotient. First do some algebra with the Newton quotient, and then let h go to 0. Then we can actually get the answer. Okay, so let's do another example. Let's do a more complicated example. How about y equals 1 over x plus 1? Or in other words, f of x equals 1 over x plus 1. There's just two ways to write the same thing. And we want to find the derivative. Well, first do the Newton quotient. Let's see, we do f of x plus h minus f of x, and then we'll divide that all by h. So I guess we have to plug x plus h into here. So x plus h plus 1 over, and then minus f of x, which is 1 over x plus 1. All of that divided by h. So we have to do some algebra before we let h go to 0. Otherwise, we're going to get 0 divided by 0, which doesn't look like any answer that I know of. So let's see. How do we subtract fractions? Like if I had 1/3 minus 1/5, I would put them over a common denominator, maybe 15. So this would be 5/15 minus 3/15, and then I can subtract. So I'll do the same thing here. The common denominator will be x plus h plus 1 times x plus 1 minus so all of this is the numerator. Take a moment to make sure you see how I got there. Now I can actually subtract these, and I get x plus 1 minus x plus h plus 1. All of that divided by x plus h plus 1 times x plus 1. And all of that will be divided by h. I get an x minus x, a 1 minus 1. And what this will be equal to is the top here will become minus h. What's the bottom here? Well, something. I could expand it out, but I'm not going to, in case I don't have to. Now the divided by h, I could write like this, or I could just write it like that. So this is something to do with fractions. You need to know that I can take this thing and put it like this. Okay, so the idea here is, if you have 3/4 and then divide it by 3, that's the same as doing 3 divided by 3 times 4, which would then be 1/4. Okay, and so this h here can kind of slide up into there. And you have to be really careful with this. So you have to know how to manipulate fractions well. What'll happen then is that this h will cancel with this one. And I will get -1. Don't forget the negative h divided by h is -1. Divided by x plus h plus 1, x plus 1. And now I feel like, can I let h go to 0 and get something that is meaningful? And yeah, I can. What do I get? Yes, I get. Now, this thing is, in the limit, it'll be our derivative, and the answer I get is -1 over x plus 1 squared. Okay, and that's my answer. So, as h goes to 0, this just becomes a 0. X plus h plus 1 just looks like x plus 1. I have x plus 1 times x plus 1. That's just x plus 1 squared. By exponent rules, I could say this is negative x plus 1 to the minus 2 if you want, but I prefer this format. These are identical, and these are both true. Okay, so that shows you how to compute derivatives completely in general. And so now you should try out these exercises yourself. Now, before I leave, what is the right and left derivative? Well, when we wiggle to the plus h, I've always been wiggling to the right, but we could also wiggle to the left. And really, if the derivative exists, it shouldn't matter which way you wiggle. So if we take h positive, we're wiggling to the right, but if we take h negative, we're wiggling to the left. And sometimes it matters. So an example of when it matters is a function like this. This absolute value function, the absolute value of x, is either equal to x if x is positive, or it's equal to minus x if x is negative. So the absolute value of 5 is just 5 because 5 is positive. The absolute value of -3 is negative -3, which is 3, because -3 is negative. So this will matter when you're plugging in your formula. And I will let you try to figure out these problems here.